we are in a time where there has been there's a lot of distrust of science, and then the value and the veracity of science. But at the same time, I think it's important, right? It's important for people to be able to ask questions and to contribute. So, I like the renewed enthusiasm towards empowering people to believe that they have control over their own health, because I think that's critical, and that's important for my message as well. But what I hope is that it's grounded in objective and scientifically plausible ideas that have been tested.
Welcome to High Agency, igniting conversations with inspiring people, leading transformative change. Your brain isn't just aging, it's actively rewiring itself. And the way it reorganizes might predict your cognitive future decades before symptoms appear. Scientists have discovered that human brains form roughly 12 to 14 interconnected networks that operate like coordinated teams rather than isolated regions, which changes how we think about memory, attention, and the aging mind. Years ago, researchers took this discovery further by turning brain data into sound. Through a DARPA-funded project, fMRI, that is functional MRI, scans were transformed into audible patterns, allowing scientists to literally hear the difference between resilient brains and those heading toward decline. This sonic approach revealed hidden signals that visual analysis alone might miss. And that's what this area of research is all about, identifying patterns that could revolutionize our understanding of change in the brain. And perhaps most surprising is that where you live might matter more than your DNA when it comes to brain health. An NIH study tracking middle-aged adults across Dallas-Fort Worth found that socioeconomic factors were creating detectable brain signatures decades before cognitive decline, patterns that challenge long-held assumptions about genetic destiny. And today, we're joined by a scientist leading some of these breakthroughs. Dr. Gagan Wig, who directs the Wig Neuroimaging Lab at the Center for Vital Longevity. Dr. Wig is the program head of cognitive neuroscience and associate professor at the University of Texas at Dallas, with appointments in the School of Behavioral and Brain Sciences and the Department of Psychiatry at UT Southwestern Medical Center. As director of the Wig Neuroimaging Lab, he leads research exploring brain organization and aging. Dr. Wig earned his PhD in cognitive neuroscience from Dartmouth College and completed his postdoctoral fellowships at Harvard University and Washington University School of Medicine. Dr. Wig, Gagan, welcome.
Thanks, Mo. Thanks for having me.
So how many memories can the brain hold? Some say it's 4. I disagree. Care to respond?
4 is the correct answer.
Perfect. Moving right along.
Do you want an answer for that?
Yeah, because it's, like taking a very cursory view, I'm obviously not a neuroscientist, of your research and the work that you do, is very different than, I think, maybe some of the metaphors of the brain that we've grown up understanding, of thinking of it, oh, your brain's like a computer and your memories are like the RAM and long-term memory is like the hard drive. And I think a lot of what you guys are doing is changing how we even understand how the brain works. So yeah, I mean, as we think about aging and having long lifespans, let's start there. How many memories could the brain hold? Is there a limit?
Yeah, I mean, it's a great question. I think that's, it's one that we don't have full understanding of, and maybe the short way of answering that is that it seems unlimited. Even as we age, we tend to lose our ability to rapidly recover memories, and we might even lose some. But we do acquire new memories as we grow older, and it seems unlimited to some extent. So the idea of holding a memory and what the capacity of that is, I don't think we have a firm grasp of that. Yeah,
I think like even the idea of memory being something that isn't like maybe as static as we thought it was, is a little unsettling, right? Because actually, I learned from you years ago that memories are actually reconstructed every time that they're accessed. And I think for anybody that has, even a little bit of like an OCD tendency, right away that just seems messy and disorganized. Because it's like, what do you mean it's changing and reconstructed every time I access it? Because it is a little unsettling, right? We like to think of a lot of our perception and our reality as being static. We like to think about our childhood, our memories of our past selves as being something that we can access at any time, and knowing that we have an understanding of ourselves. But the idea that that is actually changing, it's in flux over time, like I find it a little unsettling.
Yeah.
You know, has it changed your appreciation of the brain, or like how you think about maybe your own memories?
It has, and I understand the unease that comes with that. I think when you realize it's more of a feature than a bug, the fact that memories are reconstructed means we're able to edit them. We're able to reevaluate what might have seemed like a given experience that had a certain emotional bend to it, or something that was unsettling, and reevaluate that memory to give it another perspective, and that's critical, right? And that's critical over the lifespan to be able to reevaluate memories and even re-edit memories. The reconstructive nature also allows us to imagine future selves that haven't happened yet, right? Without memories of things that had happened and being able to put them together in different ways, we wouldn't be able to imagine what's possible. So I think there are a lot of reasons why that feature is critical and allows us to be flexible and think flexibly and plan flexibly and imagine destinies that haven't happened yet.
Well, like, what are the mechanisms? How does the brain decide? Like, I'm a very nostalgic person, right? I like to think about what happened, these cool moments in my life. Like, why can I only remember certain birthdays?
Yeah, I mean it's a remarkable, again, aspect or character of memory that seemingly, the seemingly mundane things we remember with like such vividness, and the things that you really want to remember, they get lost, and it's not clear why that happens. There are ways to promote memory if there's something that you really want to remember in the future. There's ways to try to improve the likelihood that that would happen, by revisiting them, by thinking about them often. The act of retrieval really supports, the storage of memory. But there isn't a quick solution for this. And any attempts to do this, via like pharmacological, interventions or brain stimulation, those have fallen short. So it's a long-standing question in cognitive psychology and cognitive neuroscience more broadly.
Well, I feel a little bit better now because no matter how many podcasts I listened to or how many products I've bought based on Instagram reels that I saw that were promoting, neuron development or something like that, I can tell you for the past 2 years, I think they've had like close to little to no effect in improving my mental state or ability to access memory. But what causes somebody to actually like study the brain? I mean, it's fascinating now that you're here. You obviously had a long history in cognitive neuroscience now and some very deep research in this field. But what set you down this path in the first place? Like, was it some early childhood fascination with the brain, or did you trip into it accidentally one day because you sat in the wrong class?
Yeah, I mean, I think it's more of the latter. It was much more organic.
You sat in the wrong class.
I was in the wrong class. No, I think my trajectory, early on, I took seriously some advice that my dad had given me, just about what, how to pursue a career or think about what you want to do. And my dad really pushed the idea of focusing on things that you enjoy and that you excel at. So I took that to heart, and I was really young when I got that advice, and that message got reinforced several times. So even in university, I was on a particular path that was a little bit more geared towards medicine, and I got some good advice from a family friend that resonated in the same way. That ultimately you want to do something that you enjoy, and then if you enjoy something, you'll succeed at that thing, and then that opens up doorways to you. And I identified psychology as an area of interest, and the brain as an area of interest that I didn't know much about, and I ended up really enjoying studying it as an undergraduate, and things just progressed in that way. I realized I have a joy in research that wasn't being met in other areas, and that this was my calling. So that's really how it started. And in terms of the exact questions of neuroscience and psychology, the brain and space are like the two frontiers that it's just uncharted territory that we don't have full comprehension of. So it seems just like such a rich sandbox to explore in and understand and try to learn better.
That's actually really interesting. I've never thought of those two things together like that, right? Of like the inner world and kind of like the outer universe of the brain and the space as being uncharted territories. Um, so you say you enjoy psychology, but why, right? I mean, I think it's cool that your dad gave you that advice. I think sometimes it can be seen as a little bit of a platitude as well of like, oh, follow your passions, do what you enjoy. And there's a lot of broke artists that would tell you that sucks. But, here, obviously, there was an area that you had a passion in, that also you were able to express some excellence at. But what was it about psychology? Like, what was it early on that actually attracted you towards it?
Yeah, I think again, having like, I think we all have we all have a hypothesis about how the brain works, how our mind works, right? We all have ideas about our own inner workings, and we're all able to test some of those ideas sometimes, and evaluate our cognitive function, or sensation, or perception. So I think just that intuitive sense of, oh, this is an area that I might have an intrinsic interest in because I have the cognitive capacities that I'm studying, and I have some insight. It might be wrong, but I have some insight as to how things might work. And what that means is I can generate ideas and questions and hypotheses. And I think that was really what kind of led me to it. That there was, I didn't have to study a lot to have an idea about this field. So I think maybe that was, is like you're able to dip your toe in. I think we all have pet ideas about how the brain works, and just that comfort gave me an opportunity to enter the field. And then as I learned more, I realized how little we know, and how much there remained to be discovered.
What do you mean by you didn't have to study a lot to enter this field?
I mean, I think we all have ideas about how the brain works and how cognition works. So it doesn't take a lot of background knowledge to have a hypothesis about the inner workings of the mind, and they might be wrong, but it means that we have the opportunity to learn and discover once we engage in the science of it.
So if you were headed early on towards, I'd say maybe some, a bit more of a classical career of like medicine, as, a young brown kid of immigrant parents, I am as well, many others are. There's sometimes a lot of pressure to like fit into certain career paths, but it sounds like your family gave you a lot of latitude to do what you wanted. Maybe do what you wanted as long as it's sciences, or was it literally do whatever you want?
I was fortunate where it really was, the emphasis was on doing something that I enjoyed.
So it could have been anything. It wasn't like,
I think so.
as long as it's sciences, let's do whatever.
Right. I guess we'll never know because I never, I pursued a path that excited me, and that kind of did fit a mold of sciences. But I felt comfortable and secure in what I was pursuing, and I didn't feel like I needed to uphold someone's requirement, or my family's, what they expected of me, as long as I did well and enjoyed it and was happy. So I think having that comfort was really critical.
Did your family understand what you were doing when you embarked down this path? Or was it just kind of like, well, as long as you're happy, okay?
Right. I think to some extent, they knew I was studying the brain. They knew I was, was interested in science and research, and with my dad's an engineer, so he understood, the research, the pursuit of research, and the importance of it. But it's even to this day, it takes a little bit to like really communicate what exactly we're studying. And they understand we study aging and Alzheimer's disease, and the way we're approaching it.
Is there any like additional or new urgency around studying aging in the brain? Because I mean, it can be a pretty, like, I still find the whole field unsettling. Like, I like to read about consciousness and, quantum physics at a high level, that almost borders on the metaphysical because it's abstract and it's far away. But really talking about like the gray matter of like how it's aging, how it might be declining, how it might be reorganizing as you get older, and potentially even failing. Like these are all very unsettling things for me. And I think I'd, perhaps just come home depressed from the lab every day if I was studying aging in the brain. But is there anything in particular that's driving this particular urgency, or has it just been an area of fascination?
Yeah, that's a great question. I think there are several things that make it a critical area of inquiry. Uh, you know, Demographically, we're living longer, right? The population is reaching eighth, ninth decades in greater and greater proportion. That's largely due to the innovations in other systems of body and health, right? Cardiovascular function, immune function. So our bodies are living much longer. Brain science is behind though, right? As we advance in decades, we're more and more vulnerable to age-related brain disease. So there's this disconnect, right? Where our bodies are living longer, but we're still vulnerable in terms of mental and neurological health, adverse effects of mental and neurological impairment. So that there's a pressing need to really better understand aging brains and the factors that minimize the deleterious effects of that advanced age. So that's one big one. I think the other thing is kind of relevant to what you mentioned, right? We tend to think of aging as a decline in cognitive function. That's stereotypical for how we think our years are going to progress. But that's not entirely true. There are a lot of ways in which we maintain our cognitive functions either maintained or even improves over age. And that's like seldom discussed, but it becomes such a critical element of an aging process and understanding aging individuals, because there's a major opportunity then. Once we acknowledge that, there's an opportunity to leverage that and to promote a society where everyone can contribute in different ways and contribute their unique skills and their unique abilities, which might be age specific.
I didn't think anything about the brain improved actually with age, but you're saying there's areas and functions that get better over time?
Yeah. So a classic way of thinking about it is, if you look at like typical cognitive measures of like memory and attention, speed of processing, right? Those are like these hallmarks of cognition that do decline with age, where we're a little bit slower to respond to a stimulus or thing in front of us, or to recover a memory, to do a mental calculation. And that's the classical curve that we all think of when we think about aging, right? It aligns with, physical fitness, aligns with other aspects of health and well-being. But if you look at other measures of cognition, like your world knowledge, your vocab, those things actually even increase over time, right? Because we continue to build those and we continue to store those. So there are all these ways in which our cognitive function are improving, right? We might not be able to access them as quickly or as expediently, but they nonetheless exist, and we nonetheless have access to them. So I think tapping into that, right, is a critical aspect of understanding how to promote a society where the elderly are really reaching their full potential.
Mm-hmm. Yeah, I mean, like I'm reading a lot about. I think maybe it's just also a function of having like an aging parent. Like my mom's not crazy old, but 71, turning 72, I think this year, losing count. But you read these things about the gut bacteria and how diet is having some sort of effect on like Alzheimer's. But there's all these other factors where I think for a long time it was just lumped into a category to say, oh, you're getting older. And as you get older, there's, the brain starts fucking up, and that was it. Right. And now discovering that even things like diet have such a massive impact on it. But then there was something interesting that I was reading about, in regards to your team's research and the work that you're doing, which was around like this zip code analysis that you guys did of the socioeconomic factors. And as somebody that has a little bit of an activist bent in me, like, the socioeconomic impact on brain, brain health, that immediately, I got like radicalized immediately about, oh my God, what the hell? The system got us again. But can you speak to that a little bit? Like, what your data showed and what you're actually finding in terms of the impact that your geography has on how your brain ages over time?
Yeah, no, thanks for asking that. I think that's it's an important edit on thinking about this. we can describe trajectories of aging,
Mm-hmm.
right, in general. But as we all know, the reality is we all differ in how we age, right? Starting 20s and 30s into midlife, into older age, some people start declining pretty quickly, right? And others seem to maintain cognitive function throughout their adult years. And others, even, as I said, there's aspects where they'll improve. There's immense variability in the same way there's immense variability in physical strength or endurance. Um, so that's a reality, right? That there's differences. But I think the striking thing is that some of those differences are related to identifiable exposures, right? So environmental exposures, wherein you can see disparities in brain health that are related to socioeconomic factors, to education, to places where people live, which tells us that there are elements of what we're being exposed to that are either creating greater vulnerabilities to paths of aging, or possibly even allowing us to remain resilient. So there's a flip side to it all as well.
Is there any sort of like linear comparison where you can say, okay, there's a particular type of, socioeconomic environment that has this outcome, or is it not that conclusive?
It's not that conclusive. This all rests as well on like epidemiological data, right? You look at dementia rates as a function of educational attainment or neighborhoods, and dementia incidence is lower in amongst people who have higher educational attainment. It's higher amongst individuals who are living in poverty, and that's within a country, but also across countries. So I think a lot of these things speak to some of the knowns that we've always thought to be a reality, right? Where access to healthcare, nutritious food, access to health services, access to time to be able to sleep and get exercise. Those things are all factors that are critical towards promoting brain health, much in the same way that they're critical towards allowing you to maintain cardiovascular function or immune function. And unfortunately, there's certain communities that don't have that privilege, and some of it is due to structural inequalities. And kind of identifying the factors is important, right, towards both alleviating and allowing them to overcome those challenges, but also identifying the things that matter for a broader populace.
Mm-hmm. If we back up for a second here, if you kind of look back over your career, because you've had the Neuroimaging Lab at the Center for Longevity.
Center for Vital Longevity. Yeah.
Center for Vital Longevity for a number of years now. But if you look back at the sort of the start of your career, was this always the sort of target, or has that evolved and shifted over time?
That's evolved and shifted as well. I entered this field with an interest in studying memory, right?
Mm-hmm.
The first question you asked was about memory. So I studied, in graduate school, I studied human memory systems and how we encode new memories, how we retrieve old memories. And in doing that, I through that process, I realized that I was really interested in how memory breaks down with age. So during postdoctoral training, I studied aging memory systems, right? Looking at older age populations. During that time, I was doing a lot of work that's focused on localizing functions of the brain, looking cognitive functions in the brain, and understanding how they differ between younger and older adults. And that's it's a very important and quintessential paradigm for cognitive neuroscience, right? To identify what spots of the brain support what cognitive functions, and then how they differ across age groups or healthy individuals versus patients with impairments.
Mm-hmm.
But during that time, I also started to read a lot about an area of math and science that was referred to as network science, right? So understanding the interconnectedness of things, and how important that is towards understanding large scale systems. And the brain is a large network, right? As we all know, it's a network of interacting neurons. And there was this, teams of researchers that had started studying the brain in this very network-centric approach, right? And learning new things about the aging brain and how it develops over time. And that just excited me. I was like, this is a way to study aging, right? Aging is certainly a breakdown of networks, right?
Mm.
It's not a breakdown of a particular region. It's a breakdown in how sets of regions interact, because cognition, memory, attention, language, emotion, those aren't products of a region. Those are products of sets of regions, right? And the brain is a large network. And much of those things that we think of in terms of cognition are emergent properties of that network. So to study aging then I felt would really require an approach that leveraged that science of networks. So I transitioned to a second postdoc, and during that time I really learned about studying networks of the brain. And that's kind of what took me off, right? I moved from there to my first faculty appointment at UT Dallas, and I've been there since then, where we've taken that framework of thinking about how to measure brain function and brain structure from this network-centric approach, and we've leveraged it to better understand age-related changes and disease and the environment. So that's been the path.
So was that like a particular like eureka, this idea of looking at networks in terms of how the brain's aging, or had that been done before and you just took it further?
No, I mean the brain's been described as a network for decades, and we've known that it operates in this way, right? We knew that just by looking at the anatomy, right? Some of the early neuroscientists who studied individual neurons realized that neurons are heavily connected, right? So you have billions of neurons that are supported, and their interactions are supported by connections. So it was clear that there was a network-based aspect to how these things are working. In human neuroscience, we're limited. We weren't able to. You're not able to. You can't take a living individual and look at an isolated neuron, with some exceptions. But our primary tool has been brain imaging, non-invasive imaging, and we were limited in that we couldn't look at individual neurons, but we could look at groups of neurons or areas of the brain. So the idea wasn't a eureka, but where the innovation came was the development of tools that allowed us to study that interconnectivity across areas in living human individuals. So that's really been like the thrust of the last 15 years. Not just in my lab, but in lots of labs are studying development and disease, and that's been where all our innovations have come in, and it's allowed us to really also interact with other communities that we previously didn't interact with, right? Physicists and mathematicians who are studying other interconnected systems, and really leverage all the things they've learned in those systems to better understand the brain.
Mm-hmm. What was it in your earlier education that you think like set you up for success in this field? Was there anything that specifically really set you up for success? Was there anything specifically that you had to kind of almost unlearn as you enter these different domains, and were learning to navigate kind of like the academic realm?
Yeah, that's a good question. I think I'm inherently curious. I ask questions about everything, and I want to learn more, and I have this very I'm driven to just continue to explore, and this innate curiosity in how things work. I think that's one of the key elements of being a scientist. I enjoy working with people, groups of people, and thinking about ideas and thinking about how what we're working on has relevance to broader societal and universal issues. I enjoy seeing connections between things, right? Maybe unironically. So, even now our own work on the brain, as you mentioned, we're not thinking about the brain anymore as this siloed organ of the body, but we're trying to understand how this network of areas and neurons interacts with other networks of the economy, of social systems, of environmental systems, of other body systems. So it's really, that idea, it's permeated how we're approaching our science and how we're trying to link with other communities and better understand this organ that we're interested in.
Mm-hmm. So I want to jump off the network idea, but actually, as ironic as this might sound, let's leave the brain behind for a second. Because there's another type of network you have to navigate as well, which is just the professional sphere, right? You went to school at UBC. And then Dartmouth, you did your PhD. And then where'd you go after that? It was
To Harvard.
Harvard, and then
WashU.
WashU. Okay. So we're talking about, a lot of institutions that are in very different spheres that likely have different academic cultures. And this isn't just, you as a scientist working by yourself. It's a very Hollywood-esque picture, right? Of the guy with like beakers everywhere and just in a lab by himself researching, and then there's a breakthrough. But there's people that you're working with, right? There's collaborators, there's, people you're learning from, there's people you're mentoring. But what was it like navigating the professional networks of this side as you kind of moved through these different spaces?
Yeah, I've like been lucky to work at some great institutions and train in great institutions, and I think I've also been lucky to uh, train in communities that were all different from one another. So, as an undergraduate, I majored in biopsychology. It was in the Department of Psychology at UBC, and my PhD was also my PhD in was and the first half of my postdoc were also in psych departments. But then I transitioned to a medical school in the Department of Neurology, and now I'm currently in a center that's a little bit more integrated across numerous units of the school. So it's not a med school, but it's also not a psych department. And I think the diversity of those experiences where there are different cultures, and different ways work and research and scientific questions are asked. That's really allowed me to think more about how I run a team and how I run a lab, and and what I want to accomplish. So I've been lucky in that way, and I'm really thankful for that. Not only did it expose me to being able to work in different organizational frameworks, but also um, be exposed to people from like just phenomenal like backgrounds and having with phenomenal skill sets and ways of thinking about this common problem, but that are all different, but all unique and critical, and it's allowed me to appreciate the importance of that diversity in thinking.
Mm-hmm. I mean, looking back on it now, when you look at your experience and what you've done, it all just seems like this like really gentle, long master stroke of one thing, just moving from strength to strength, from one area to the next. But was there ever a time or an area where you got stuck, where you went down a road and were like, oh shit, that wasn't it, and you had to like back up and start over and like head in a different direction?
Yeah, I think yeah, I thought I knew what I wanted to do initially, in terms of studying memory systems and focusing on them in aging. And I just felt that wasn't my calling at the time, the way I was studying, studying the brain. But I wasn't sure why. I felt like I was limited in the types of questions I could ask, and my own creativity. And that was really like a me thing, because the field has moved since then, and they're doing remarkable work. But I got really excited and inspired by this other way of thinking about brain function and brain organization, and I think it renewed my sense of enthusiasm. And it was somewhat of a risky transition, right? Because I was on like an idyllic trajectory, but I could feel the momentum slowing down. So I think being able to recognize that, and then make a move, and be able to make a move, having an opportunity to make a move, that was important, and that really did allow me to build a career that now I'm just I'm very much immersed in, and I'm thankful because I'm excited every day about the work we're doing.
Just for comparison, what was the idyllic trajectory that you were on?
Oh, just in terms of like the institutions I was going to, and like it was like very quintessential cognitive neuroscience, studying localization of, cognitive operations and approaching the brain in this very, in not a reductionist way, but trying to map functions to specific spots.
Mm-hmm. So what was the risk of going into a different or a new area at that point?
Right, because anytime you reset and have to go learn a new method, right?
Mm-hmm.
You're essentially resetting your clock in academia in some ways. When you're in that postdoctoral phase, right after you've done a PhD, it's normal. It was, especially back then, it was normal to transition to a faculty appointment. But rather than taking that typical path, I identified the fact that I had this gap in my inspiration. So then going and learning a new skill set and learning a new way of thinking about the brain, that was the important inflection. and that prolonged my training, right? So that meant I essentially doubled, the post PhD training period, and that could be really risky.
Yeah.
Yeah.
What did your like contemporaries or your mentors at the time say? Were they generally supportive, or was it any skepticism of what you were planning to do?
Again, I think I was lucky in that even the people I was working with were really supportive of me transitioning to something different. They recognized my interest in it, and I think they also recognized the value of thinking about the brain in different ways. Yeah, I think again I'm fortunate where I didn't feel as much resistance as I certainly could have.
Mm-hmm. And so I mentioned before the idea of like, the quintessential Hollywood image of the scientist working away in a lab by himself. You're obviously bringing a lot of people with you. So what does your lab look like today? Like how many people are you leading? What does it even mean to lead a lab like this? Like how does that work?
Yeah, every lab in science looks different, right? Depending on the discipline, it could range from one person, in front of a Bunsen burner to like, a team, team of 100. And even within my discipline of cognitive neuroscience, there's a broad range in the number, and then in kind of the kind of the types of trainees and lab members. Um, uh, and I think people have different philosophies, and what works for different people just varies. For me, I really enjoy being directly involved with all the projects in our lab, which has put that what that's led to is a constraint, right? I know my capacity is for managing scientific projects. So I tend to have a team that's kind of allows that, right? It allows me to not be spread too thin. And that's, it takes, there's like, active, you have to actively evaluate that. Like, what am I comfortable with? And at what point am I going to be spreading myself too thin? So currently there's, one staff scientist who she has a PhD we've been working together, since she got her PhD. And then there's another postdoctoral trainee, and then there's 3 PhD students, and then several research assistants. And that tends to be the composition of the lab. And everyone has their own projects, but we work as a team, and we collaborate on all the research we're doing. So that's the local environment. The beautiful thing is that we get to work with lots of other researchers and other institutions and through collaborations. So that, it does kind of increase the social network of what we're doing. But it allows us to ask lots of different questions and engage with people working in animal models and disease models. So that, so I have a more of a local community that's sitting in the lab, but then in a broader scientific community that I engage with.
What did you have to learn about working with people? Because I mean, it's obviously very natural to have a curiosity about your field, of course, right? There's a lot of learning that happens there. But was there anything that surprised you where as you were kind of progressing in your career and now not just, being trained by or learning from mentors, but actually starting to become a mentor yourself and learning to actually bring people along with you? Was there any specific moments or any specific skills that you remember as having to like learn as completely new? Like, oh shit, this is different. This isn't just research anymore.
Wow. I think it's kind of an ever evolving thing. I think I'm constantly realizing my, areas I have to develop in, and my strengths, and trying to create some balance across, what a leader means, be it someone who's in the weeds versus someone who's more of a visionary versus someone who's connecting with the team socially, and just like, on a personal level. The funny thing about academia is you train, your training is all about the science, right?
Yeah, that's what I was asking.
Typically.
Yeah, because it's so focused.
Right.
But when you're in a leadership role, it's like there's a whole slew of other skills you actually need to be effective there now, right?
Yeah, there totally is. And we kind of, we reflect on it often, right? Especially when we're hiring new faculty. So, the one funny example is that if you're in an academic institution, you're as a professor, and it's a research institution, you're typically getting hired based on your research, but you're also being hired to teach. Yet a PhD doesn't afford you formal training typically in teaching. You're kind of just thrown into it, right?
Really?
Once you get the job,
Yeah.
and then you have to learn how to teach, which is not it's not trivial, and many people can't teach effectively.
Mhm.
Um,
So,
and
so there's a teaching function to what you're doing as well.
sure, I teach, a couple courses a year, and that's very normal for someone at a teaching research university. I think the exceptions would be if you're in a research group that's like in a medical school where there's no teaching. But normally, most academics in research universities are teaching a few courses. So there's an element of teaching, which was, it wasn't a surprise, but it was a little bit like getting just, thrown into this thing that I never received formal training on. There's an element of HR, understanding, how to navigate, dynamics of into people and finding the right people to hire to build your team. It's not something you train in, right, as an academic, right? Again, you're typically, we don't wear lab coats in cognitive neuroscience, but like, you're typically really hunkered down in front of your computer and you're focusing on the data and you're just like nerding out about science, right? You're not, and there's quirky personalities everywhere, and most scientists are pretty quirky. So now figuring out how to build a team with all these quirky personalities and accomplish this goal, this vision, that's challenging, right? And we make mistakes doing that because what works really well in science might not work in team science, and that's a constant learning process. Even like just business management, right? Running a research lab, you're essentially overseeing a large scientific budget or a scientific budget, right? It can range from thousands to tens of millions of dollars, and understanding that the accounting and projecting into the future of like what our resources need, what our resource and staff needs are going to be. None of these things are trained, or you train in none of these things as you pursue your scientific degree, but you have to quickly figure it out.
So that's a pretty massive section of things that you're learning on the job, basically. Is there, you mentioned science and team science, and I guess the question I was actually asking was around the team science side, right? Do you ever run into a situation where you made a bad hire, or there was a personality that was maybe a little bit too quirky introduced to the team and you had to like figure out the dynamic?
Yeah, it does happen. I mean, and that's the reality. And it's, I think, the funny thing is, because as someone who's ultimately making the hire, right, at the last say in like who comes into the lab or who doesn't, there's a lot of ownership of like that decision, right? You have to have ownership because you're responsible. And I think that the challenge is recognizing when it's not working out. And there are lots of circumstances when it doesn't work out, right? Either because there's a clash between you and that individual or the team and that individual. But it's, I think it's humbling to like, because what you're ultimately doing is because everyone has the potential to succeed in like most things. But it might not be the right environment for them to succeed in, and it might not be the right dynamic. And then just being able to say that, okay, this isn't working, and we have to figure out to transition away from this relationship. That's challenging. In science, people are committing, especially if you're doing your PhD, you're committing 4, 5, 6 years. And then being able to, a few years into it, being able to say like, okay, this might not be the right lab. This might not be the calling, and that's difficult. And as a principal investigator, it could be tough to like have that conversation, but it's a necessary conversation, and it's important to have those conversations just to understand like where the person's at and where the dynamic's at.
Yeah, I mean, what you're describing is what we often talk about as culture fit, right? Where, This is like my common refrain is that you can have the best strategy in the world, but for whatever your plan is, whatever the strategy is, that's typically governing like maybe a half dozen decisions. But then culture is driving like the 10,000 decisions in between all of these moments, right? So we're constantly trying to navigate and shape our culture. What sort of culture do you think you create? Like your team that's around you now, how would they describe your leadership style if we were to ask them?
Oh, yeah. I mean, I think we talk about it informally. I think I pride myself in being present in our lab, which again that might seem like it should be obvious, but it's not it's not always the case that people who are running labs are always around for everything. But I enjoy being involved. I enjoy, we all sit together. I have my own office, but I tend to sit with the lab when I can. I enjoy doing that. We do collab. People don't have independent projects, but we work together. One of the aspects of our science is that we're bringing together tools and approaches that vary, but they're pretty complex. So I think it's what it requires is for everyone to recognize that they can master one technique or one approach towards studying the brain, but that ultimately they're going to have to come together as a group in order to leverage each other's strengths. Where other people have mastered other techniques, and I'm part of that, right? Where I know how to do certain things, and even to analyze the brain in certain ways. But then there's others in the lab that have been there longer than me now that are much better at different things. So we do really kind of focus on our team-oriented science. And I guess that's the major theme of like our culture, just being able to be open and humble with one another, so that we can like achieve the goal.
Mm-hmm. Yeah, openness is pretty huge. I also talk about this study that Google did like years ago. I think it was called Project Aristotle, where they studied thousands of companies, and of course Google, being the massive company they have so many teams. And they're always trying to figure out how to improve and how to actually, get the most out of their people. And I think what they'd actually narrowed everything down to was a single factor, which was psychological safety, right? And they found that, many other factors, of course, will impact a team's performance, but psychological safety was the one thing they could point at time and time again, right? Mm-hmm. Are people able to open their mouths and challenge an idea or share what they're really honestly thinking and feeling? Because I think in team environments, especially, like I've definitely been guilty of at times creating environments where it was like high trust but low honesty, where people believe we're all here for the same reason, but that sense of openness wasn't necessarily there. So then you kind of have like blind faith, right? Where nobody's really clear on where they're at or other people are at, but we all trust each other, mm-hmm. right? So we're just kind of going for it, and trying to cultivate more of a sense of having trust, absolutely, but like a real open and honest environment as much as you can, and making people feel safe to actually fully express themselves, right? That's pretty huge.
So yeah, can I add to that? Yeah, I think that's such a critical aspect of any team, and in science, it's so inherently important for that to be part of the culture. Science it's ever evolving, even within our lab, right? Like there's constant editing of our ideas based on new evidence. And some of that is because, you have a hypothesis and you test it and, something pans out or doesn't pan out, and you edit your hypothesis or go back to the basic idea. But it also happens due to errors, right? Mm-hmm. Errors in analysis and errors in the kind of scientific process. And that's been, fortunately the lab, we have established a culture where we applaud the identification of errors, and it's promoted transparency, right? And mm-hmm. there isn't a fear of making mistakes. Some of those mistakes can be costly, right? In terms of how much work has been put into them, right? In terms of resources. And one thing that I'm really proud of the lab is that they've, when we identify errors, we talk about them very openly and really quickly, and then the lab comes together and goes back and then works as a team to fix those errors. And some of these things will take, reprocessing data or reevaluating the study design to begin with, and it could cost months, 6 months, 7 months. But that ability to to communicate that, I think that's been really important for us, and establish that early enough that it minimizes the likelihood of it occurring over and over again.
Mm-hmm. Yeah, and I imagine in academic spaces, especially, that we feel that culture of critique. I'm sure, you don't have to name names or point anybody out, but I'm sure there's plenty of environments or maybe teams that exist where maybe the culture is a little bit more like cutthroat and accusational, actually, and maybe people are less inclined to call out others' errors, let alone their own, because there's a fear around sunk costs and time investment and what have you. Like, have you been a part of a situation like that ever, where the culture wasn't around like openness and transparency and psychological safety, but was maybe a little bit more like critical to the point of accusational?
I think that's actually really common in science, right? Like
Oh, it
the
is.
whole the peer review process, both at the level of journal publications and grants, they're typically anonymous, right? So that creates this barrier to really allowing a place where you could have constructive criticism, right? Because there's less back and forth when you have these systems in place where there's someone submitting a document or an idea and then someone critiquing it, and there's seldom opportunities to like kind of revisit and kind of
Mhm.
revise, with some exceptions. One thing we I think we've identified in our lab is that we're probably our biggest we're most critical of our own work. So it takes us longer to get things out. But we really enjoy taking the time to be the biggest, have the biggest critiques of our work coming from ourselves. And I think that's important. That's allowing, it allows us to kind of evaluate our assumptions and what we're doing in ways that we might not receive from a broader community, right? Because it's kind of cloaked by the process.
Mhm. What have you learned about yourself as a function of having to run teams and run people?
I mean, I'm pretty detail oriented. I've learned that about myself. I think I'm a bit of a control freak. I think that's an honest reality that I'm coming to terms with, and that I'm having to let go of. I think earlier on, and I don't think this is abated, but I think I was micromanaging, and I think I enjoy micromanaging, but coming to terms with the being able to let go is kind of a critical thing I'm trying to evolve into. So I've learned that about myself. I think I've learned that I really enjoy big ideas, and I enjoy thinking about application, but I also spend a lot of time in the sandbox of what we're doing, maybe to a fault, right? Where we spend a lot of time on the science, and ultimately our questions have a lot of translational value for thinking about health and longevity and aging. But we haven't really thought too much yet about how to take that step. Speaking to I know there's the running theme of entrepreneurship here, but that's something I still have to cultivate, right? Like how do we make that transition and think about scaling these ideas or promoting these ideas or making them accessible and deployable in a way that allows them to be leveraged in healthcare settings.
Mm-hmm. Yeah, I mean the micromanaging, that definitely resonates with me because I'm not sure if you're the same way, but I'm challenged, personally in pretty much only being able to sort of function in two modes, which is either I'll walk into a room and do like the vision at 30,000 feet and tell a story, or I'm like, get the fuck out of my way, I'll do it myself. And I vacillate between those two, but the idea of, sharing that middle layer of knowledge and information and disseminating and collaborating and bringing people along and being a part of the team, I still struggle with it, right? So
It's tough, yeah, and like yeah, and I think like the relaxing the judgmental, when you operate on those two levels, then when things don't work out, there's like a lot of judgment, right? So then it's like, well, why don't I just do it then? But being comfortable with giving people the latitude to figure out their own path towards getting to that high level vision is important. And I think we can have a vision of how to get there, because we have a vision of a goal, and you might know how to implement it, but then we also tend to have this idea of how to get to that goal from the implementation.
Yeah.
And it's easy to fail to recognize that there are a lot of paths to that goal, and it doesn't have to be your path. And if you're giving giving the opportunity by your path, but yeah, I think, and that's that space, that those other paths are where the opportunities are too, right? That's where we might discover other goals or other hidden factors or opportunities.
Yeah. Oh man, this is yeah. I mean, this last part is hitting pretty hard because actually just before we started recording, I was just catching up on some work and some messages from the past few weeks, and I was looking at like my tasks in our project management system, and literally like the top 3 high priority items are all things that I don't need to be doing. But I literally just ran in and snatched away from somebody, but like, give me that. I'm going to do it.
Yeah, yeah.
But I don't need to be doing that. Yeah, there's multiple paths to get there for sure. So how are you like negotiating that on a day to day? Like are you reformed fully
I don't
or
think I'm fully formed. If I mean, I think it's just it's a process, and the funny thing is it sort of it gets reinforced outside of the lab, right? And I don't know which direction it's coming from.
how does that?
I think just in the way in my life, even right, like
Mm.
thinking about like childcare and things, right? There's this reinforcement. So I think this idea of like kind of understanding multiple rungs of the process it can allow for self-improvement in like family and friendships, and even just like self-care. So yeah, I think I've come to realize that as much as I thought work was compartmentalized, it really isn't, because the way I am at work might kind of spill over into the way I am in lots of other things.
Yeah, one of my favorite phrases is the way you do one thing is the way you do everything.
Yeah.
Because you might not know this, but Gagan, the neurons that fire together wire together. So there's that. So um, so like getting back to your work for a second of the aging, the brain. There's also this sort of like hype machine out in the world, right? And I mean, you guys are obviously doing really deep work, very critical and obviously very sincere. But how do you kind of negotiate that with what's happening with like the hype machine of the world with, the Don't Die movement and
Yeah.
Brian Johnson and all the rest of it? Is there any amount of that like impacts your funding, or like even the narrative around your work? Or do you just kind of leave that at a distance and continue doing your thing?
Yes, that's a great question. I'm a cynic for a lot of the hype, because I think a lot of it is still isn't based entirely on grounded science. But I'm also interested in it because I think there are signals out there related to some of these things. If there wasn't, there wouldn't be as much hype around them, right? There are at least some signals. But we do think a lot about like some of this like biohacking in terms of what that means and how that might be if there's an opportunity to better understand signals from other body systems, and how they interact with the brain. Um, you mentioned at the outset our project on midlife. I think that's another area where we're not trying to innovate necessarily in like this science, but we're trying to innovate in like where science asks questions. Typically, studying aging meant studying older age individuals and comparing them to younger age individuals. But in older age, a lot of the things have already been set in motion, right? In terms of disease or cognitive decline, and the big question is, can we detect those things earlier, right? Are there factors that are predictive of older age decline that you can identify in middle age adulthood? And that might not seem surprising, right? Because that is the case for other systems of the brain, of the body. You can identify risk factors for cardiovascular illness in your 30s and 40s, and you can intervene on them, right? We go get our annual checkups and we do that, right? Or a general physician will measure your blood pressure, measure cholesterol. But what do they do for you in terms of your brain function?
Nothing until it's intervention time.
Right.
Yeah.
They'll ask you, and I think it's only really recently they ask you about mental health, right? Of your mood and your well-being. But, there might be a cursory question about your memory, but most of it is left to self-report. And then at that point, there are some follow-up tests, but it's not part of a standard battery. And the reality is that the reason there isn't much that's done is because we haven't identified those signals yet that we can measure to see if there's any risk factors. So, part of the work we're doing is to really focus on midlife as a period, as a time to study aging, because I think a lot of the things that we see downstream are set in motion in your 30s and your 40s and your 50s. And there's enough plasticity where there's an opportunity to intervene at that time, right? Where you could modify your behaviors, you can modify your lifestyle. And much in the same way that you can, start to slow down cardiovascular illness or illness in other domains, you can hopefully do things that will promote healthy brain aging.
Is that a part of you guys' work at all? Like the communications, the advocacy side? Because I mean, even just thinking of like the number of foundations and government grants and the funding that it takes to do this sort of like deep science. Is there a type of advocacy you have to do for yourself to like communicate what you're thinking about and even some of the things you're sharing here?
To some extent, we have the part of the messaging is to convince federal agencies and foundations that the science is worth pursuing, and that entails making a cogent scientific argument so that a reviewer will read it and say like, oh, there's value in this. But then in terms of promoting the findings, I think it's interesting because a lot of what we find in terms of maintaining brain health and cognitive function are the kinds of things that where the messaging has been there for a long time, right? A lot of the things that support brain health are the same things that support cardiovascular health. And unfortunately, people don't want to hear it, right? They want to hear there's a pill. They want to hear there's a stimulator. They want to hear there's give me an app. So I think, this is a little bit of like a slow burn where it's like, well, I think the more and more that we're able to demonstrate that, okay, there's these are the factors that matter and that they're pushing these signals in these specific ways. I think that would allow that quantitative nature of things to really permeate the mindset, right? I think that's why, in other health systems it works, right? Mm-hmm. You see, you measure your cholesterol and you can see those numbers changing, or your triglycerides, and then you act on it, right? But in the absence of those measures, of those biomarkers of function, I think it's hard for us to take the messaging, right? It's hard for us to really adopt a lifestyle of promoting sleep, promoting exercise, promoting socialization and mental stimulation. But having those markers, those measures is critical, and that's the focus of a lot of the work we're doing, and we're coming at it from lots of different angles.
Mm. Is there like a specific hypothesis, or is there like any specific intuition you have where you've been trying to get a particular answer, or at least try to get a particular question answered that's been like elusive to you? Like, do you have a white whale of some sort?
I think the more we explore these measures of brain function that we're interested in, the more we're interested in the underlying mechanism of what's leading to the changes, and the more we're appreciating the limits to some of the work that we do in human neuroscience, and where there's a need for other model systems to better study the mechanism. So just to kind of clarify, so like you at the outset, you mentioned that the brain is a large network, right? Mm-hmm. And that's composed of, I don't know if you use the word communities, but it's essentially there's modularity in the brain, much like mm-hmm. there's modularity in other social systems and other technological systems, and that modularity is critical, right? So you have sets of areas that contain many neurons, and those sets of areas in the brain, what they allow you to do is recall the past, to attend to something in your environment, right? So they all have functional specializations, and in a healthy young adult, right, there's a very reasonable amount of modularity, right, where you have tight interconnectivity amongst areas in those systems, and then sparser connectivity amongst them, right, so that the system, the brain network as a whole is interconnected, but you have these functionally specialized sets of regions that are interacting more so than they are interacting with other systems. And we see that in lots of other, in domains, right? That's not a surprising idea. But what's surprising is that as you look at healthy aging, that modularity decreases. So the systems become less and less segregated or independent. So they start blurring. There's a lot more interactions between things that would otherwise be very differentiated. And we think that has consequences for cognition. And we know that it does based on at least correlational evidence. So that a lot of the cognitive decline we see is probably because you're starting to lose that functional independence of things that should be independent. So that's been the big signal, right? In developing markers of that signal that are non-invasive, that are using imaging-based technologies. We also see that same signal of decline that as having relevance to predicting Alzheimer's onset. We see that same measure of decline as being relevant when we look at disparities in brain health. We see it relevant towards looking at people who vary in cognitive function. So it's got all these features. So, there's a lot of evidence now that we've been building, that other groups have been building, that have been pinpointing this aspect of measuring the brain. And now what's needed is to understand like what's causing it from a cellular level. So that's what we're exploring now, to understand if there's other systems which we can interrogate to understand these markers.
So we can see the change happening, but we don't know what, like the very specific like drivers for that change.
That's right.
Wow.
And at a certain level, like depending on your question, that might be fine, right? Because again, as a diagnostic biomarker or as a measure of function that you would want to use in a clinical setting, that might be sufficient. But then if you're interested in thinking of interventional technologies or pharmaceutics, then you need to understand the mechanism.
Mm-hmm. What are you excited about next? Like, is there anything new that is a completely fresh area that you guys are exploring or branching out in that is exciting?
So one big one and relevant to the thing that I kind of alluded to is we're really excited to explore these patterns that we see in human aging in other animals, and we have evidence now that some of the ways in which the brain ages, in terms of its network organization, is also present in mice and in marmosets or monkeys, in macaque monkeys as well. So it seems to be a very general phenomena, at least in these other mammalian systems. So I'm excited about that, because therein lies an opportunity to explore other model systems in different ways, and they all have different features of aging that would give us more insight. So I think that's really exciting. I think, thinking even more broadly, I'm just interested in the degradation of networks and the change of networks over time. That's not limited to biological networks. Even thinking about synthetic networks and how synthetic networks might evolve and what that means for functioning, and whether or not they show similar patterns of aging. And if we could learn about brain aging based on how other model systems work, I think it'd be exciting in terms of having some like crosstalk across these sciences.
Is there anything on the horizon, like culturally, socially, that could derail any of this work? Like, is there, I guess the question is like, what's the biggest risk to the knowledge creation and like science that you guys are doing right now?
The biggest risk to knowledge creation or science. I mean,
some of my politics are showing up through this question, right? Is like, we're just, the American situation is a little bit different than Canadian. Canadian one's not that far behind. It's like so much is governed by funding and where it flows and for what, right? And what's seen as quote unquote relevant science and what isn't. And it's so much, supposed orientation towards market dynamics. So I just wonder if you guys are affected by any of this. Like, is there a political or social climate that can change the trajectory of your work?
Yeah, I mean, I think, obviously we're in a unique time. Maybe it's not so unique, but maybe we are in a time where there has been there's a lot of distrust of science, and then the value and the veracity of science, and I think that has impeded federal support for funding of research. Some of the do-it-yourself science that's being done, I think that can undermine the scientific enterprise. But at the same time, I think it's important, right? It's important for people to be able to ask questions and to contribute. So, I like the renewed enthusiasm towards empowering people to believe that they have control over their own health, because I think that's critical, and that's important for my message as well. But what I hope is that it's grounded in objective and scientifically plausible ideas that have been tested using the scientific method. So I think that those are the two things culturally. I think that kind of they put a spin on things.
Mm-hmm. I mean, looking back on the trajectory of your career, assuming that your memory can be trusted, is there anything you would have done differently?
I don't think so. I mean, I'm really thankful that I've maybe there are things that there's certainly things I could have done differently, but I don't have any regrets in what I've done, and I continue to enjoy what I'm doing. I have sincere joy of I enjoy getting up and going to work. I'm excited by it, and I love talking about science with friends and colleagues, and the ideas that we're pursuing. So I don't regret any of the decisions, and I'm also simultaneously excited to uh, the openness of like branching into new territories and seeing where this takes us.
Mm-hmm. If somebody wanted to learn more about your work, where would they go?
I mean, there's a huge community of excellent scientists doing work in aging and in the brain more broadly. Our own work is, featured on our website. But I think there's obviously sources that are available online. I guess I'd recommend just scour the sources, the veracity, and where they come from. And I think
that's a scientist's response. Yeah, I'm not about to do that.
Yeah,
I guess the question was, like, has somebody written a blog post that I can read? That was actually the question.
No, there's a really good tweet I'll send you that pretty much summarizes everything we've done.
Yeah, so it's the Wig Neuroimaging Lab at UT Dallas. And thanks for coming on, Gagan. Really appreciate it.
Thanks for having me, Mo. I loved the time chatting with you.
Well, hopefully we've given you a lot to think about. That was High Agency. Like and subscribe, and we will see you next time.